everybody and welcome back to our channel today. So in our channel today we are going to be having a brief discussion about solubility product. Okay, let's have a brief discussion about solubility product. So basically we will be representing the solubility product, okay, in letter KS. So KSP, that's how we basically represent the solubility product. Okay, so let's just take any amount of solvent. Okay, let's take some solvent here. So I am actually mixing some solute here. Okay, I am actually mixing some solute here. Okay, that will what we are going to be studying about the solubility product. Okay, so in my channel, in this video I have got a lot of tricks which will help you to understand. Okay, and I can also explain some factors in which this KSP will depend upon. Okay, before studying all of this, let's try to look at one basic formula you should remember in the solubility product. But guys, trust me, with that one formula you can solve any question which comes in your way when it comes to solubility product. Okay, that is one of the easiest formula and the technique as well. Okay, suppose let's just take any random compound. Okay, I am going to be taking the compound as I'll be taking the compound let's take BaSO4. okay, so BaSO4. okay, so I have basically taken this compound. So first let's talk about one thing. You have to know about the X and the Y terms. Okay, you have to know about the X and the Y terms. So basically the number of atoms which you find in this Ba, that will be the X, and the number of atoms that you find in the in the SO4, that will be the Y. Okay, so we have a common formula. Okay, the formula is X par X, Y par Y, and S par X plus Y. Okay, so revolving this formula only, all the questions you will come across when it comes to solubility product, every question you will be coming across this formula only. Okay, you have to remember this. Now let's try to find the solubility product for this compound BaSO4. Okay, in the place of X we are having 1, so 1 to the power of 1 into, in the place of Y we are having 4, so 4 to the power of 4 into S of 4 plus 1, which is 5. So 4 power 4 is 256 S of 5. Okay, so this is the formula you get. In many questions they give you the S value. Okay, suppose they will be giving some S value. Okay, the S value they will be giving. Okay, suppose they will be giving the S value as 2.3 into 10 power minus 3. Then in this place of yes sir, you just got to substitute the value, you will get the answer over. Okay, in the place of yes sir, you have to substitute whatever value is given for yes. Okay, if you do that, you will be getting the answer. And in many questions they'll directly ask you this itself. Okay, now let's take another example. The calcium phosphate, CaPO4 twice. Okay, in this we will be getting it as 3 cube. Okay, and 2 square S of 5. Okay, 3 cube will get you 3 3s are 9 and 9 3s are 27. 27 into 4 into S of 5. Okay, so it will be 108. Okay, it will be 108 X to the power of 5. Okay, so basically XY have we written. Okay, we have to understand one more thing. They will be giving this to confuse us a lot. S can also be written as X. Okay, so S can also be written as X. And exactly right now I forgot to mention a thing. S is nothing but the solubility. Okay, what is KSP? KSP is the solubility product and S is the solubility. Okay, so like this only most of the questions we will have to write. Okay, basically you have to remember this formula when it comes to solubility product. Okay, and there are also some points which I would like to mention here. Okay, so we will take, we will be basically taking 3 compounds here. Okay, I'm going to take M2X. Okay, I'm going to take M2X, MX and MX3. Okay, so like this for sample, if you're getting any compound, you have to remember this order, that this MX3, it is basically greater than the 2x, which is in turn greater than the mx. So this order also you have to remember, okay, because they will be giving the actual compounds, okay, and using the actual compounds you have to obtain these formulas and then you have to make the order. Okay, let me just try to give some example. All right, let's just try to move on. Okay, so and another thing, okay, if you have to find any compound, okay, if you have to find any compound that is less soluble, okay, less soluble. Now I'm having a quick question for all of you. If a compound has to be less soluble, okay, then should it have high KSP value or should it have low KSP value? Now just understand my point. If it should be less soluble means the solubility product should be less or the solubility product should be more. Obviously yes, okay, if it is less soluble then the solubility product, okay, the solubility product should also be less, should also be less. Okay, all obviously right, only right. Solubility product in the sense what? It indicates the solubility of a substance. If the solubility product itself is less, then the substance is also less soluble only. Okay, these are some of the points you have to understand. Firstly, this formula, we have solved 2 examples for that, right? And this order you have to remember. Then this point you should remember, if the solubility product is less, then the the substance is less soluble. Okay, and another thing, if it is another thing, size of some atom, okay, size of some element is small, okay, size of the element is small, then what do you think the KSP value will be like? Whether the KSP will be low or the KSP will be higher? When the size of the element is small, the KSP is also less only, it is also lower. Okay, so with all this knowledge, with this knowledge you can come across any theoretical question in the solubility product, you will just answer like something very easily. Okay, the whole question paper comes around this only, the main concepts are this only when it comes to solubility product. Okay, this is an interesting concept, and as well as the main places where they'll be asking questions are this only. Any numerical question, only this formula. Any theoretical question, these points you should remember. The order is also very important. Okay, now let's try to do some questions related to this. Okay, let's try to do some questions. Question number 1. Okay, so the solubility of the calcium phosphate, solubility of calcium phosphate, okay, solubility of calcium phosphate, they have given it as x mole. Okay, they have given it as x mole. Okay, they are asking us to find the KSP. They are asking us to find the KSP. Just now we did, right? We got the answer as 108 x to the power of 5. Just now we did same question. Okay, let's try to do another question. Okay, so they have given us some salt, and they're asking us which is least soluble. Okay, they're asking us to find the least soluble salt. Okay, I'll write some options. You can pause the video real quick. Okay, you can go to the comment section and answer me what do you think it will be, and then we'll see the answer. Alright guys, so these are the options. Okay, and the the values given in the bracket are nothing but the KSP values. Okay, if you look at this point, okay, if you look at this point, it says that if the solubility product is less, then the the salt or whatever it is less soluble. Okay, so in these compounds, okay, in these salt which is less soluble, obviously the KSP value should be lesser. Okay, if you try to apply this point. Alright, so out of this I told you that in this bracket it contains a KSP value. So out of these 4 options, which option do you think the KSP is less? Okay, 4th option is the answer. Alright, so don't get confused. Since 50 is more, don't think that it has more KSP value. No, it is minus, right? So minus 50 compared to all other things, minus 50 only has less value. Okay, so it is only less soluble, because the number line goes like this. Don't get confused. Many people get confused that way. They think the 50 has greater value, so that will be higher soluble and all that. Okay, it is minus 50, so you have to consider it if you have to think it that way. Alright, now let's try to do another question. Okay, these concepts whatever we have seen, depending on that only I am giving the questions. Okay, they have given again some options: MgOH twice, Okay, barium OH twice and beryllium OH twice. So out of these options, which do you think they'll be having the lowest KSP value? Out of these three, which do you think will have the lowest KSP value? Just now we discussed, okay, just now we have discussed that if the size of the element is small, the KSP is also lower. So compared to these three, the size of the beryllium is small, right? So the beryllium hydroxide, it has got the least solubility product. Okay, so this way only you will basically get to answer the questions. All right, and let's just try to do one more small example. Okay, so this is the last example we are going to discuss right now. I have given you a compound which is MgOH twice. Okay, we are going to find the KSP, I mean the solubility product value for this. Okay, so we know that this is X and this is Y, right? So, and we also know one more thing. Okay, so they have given you that the S value is X. Okay, obviously in most of the questions, guys, they'll be giving S value as X, but I told you that both actually they mean the same thing, so don't get confused. They might also give X is equal to Y. Simply in the X place just substitute whatever is given as S over. Okay, so right now if you see that we know that this is X and this is Y, so I told you the formula, you have to apply that formula now. Okay, what is the formula? It is X to the power of X, Y to the power of Y, and S to the power of X plus Y. Okay, so if you apply this, you will be getting X to the power, only 1 is there, so 1 to the power 1, and in the place of Y you are having 2, so 2 to the power of 2, and S place 1 plus 2. Okay, so 4S cube. Okay, 4S cube is the answer. So this is the solubility product. Okay, so in the place of S, I told you to substitute X. So 4X cube is the answer. So in the place of S, they might also give you some value and you are supposed to substitute it. Then in the place of X, you should write some value and then you have to solve it and you will get the answer. But they have just given us X is equal to X. So I have just normally taken it like that. Okay, this is the whole solubility product concept that you have to understand. Okay, let's have a quick revision. So basically KSP means solubility product. Okay, and this formula you should know: X to the power of X, Y to the power of Y, and S to the power of X plus Y. And most of the cases S will be given as X only, so don't get confused. This is an example we have seen, 2 examples, and this order you should remember: mx3 is greater than m2x, which is greater than mx. Okay, and then less soluble, the solubility product should be less. Okay, if the KSP value is less, then the compound is less soluble, and the size of the compound is less, KSP is also less only. We have looked into some examples. Okay, that's it. Thank you for watching today's video. I'm very sure that you'll be understanding this concept like very crystal clear, so you can answer any type of question you will encounter in this topic solubility product. Okay, that's it about today's video. Please like this video and hit the bell icon so you'll be notified on every videos that I post. I'm very sure it will be helpful for all of you. Okay, please hit the like button and subscribe to my channel. Bye bye, we'll meet you in the next video.